Hello dear viewers, welcome to TV Mathshub. This is your study pattern for competitive exams. Here you will find different questions, clear solutions, and the guidance you need to succeed. Subscribing is completely free. It is just your way of appreciating our work and supporting the channel. So don't forget to hit the subscribe button and let's learn together. Hello dear viewers, welcome to TV Mathshub. Only 1% of the students can solve this integration problem I'm going to put here. In the world of advanced mathematics, there are problems and then there are legends. There are the questions in exams like the UACE that separate the great scores from the perfect ones. For years, a certain type of integration problem has been notorious for stumping students. It looks almost friendly, but deceptively simple. But hiding in plain sight is a trap that a huge number of students walk right into. So ladies and gentlemen, here is the question. So the question says, integrate 1 divided by 1 plus sine of x dx. So I hope this question seems to be familiar, but go on and take some seconds to think about it. Pause this video and think about your first step. So what do you think would be the first step to take in order to solve this given question? So I'm waiting. What is your first step that you will take in order to solve this given problem? Please drop your initial thought in the comment section. I am genuinely curious to see who spots the secret. So think about it. So in case you have got an idea, we shall get into this problem. So what are the common mistakes that students usually make just on seeing this kind of problems? One, I know that the majority might have solved first of letting. For example, to let u to be 1 plus sine of x. That is what some of us solved. Okay, let us see. If you solved of this one, what do you think would be? It means du dx would be same as cos of x. And this would imply that dx is same as du divided by cos of x. But when you place it there, it means your integral of 1 upon 1 plus sine of x dx would be same as the integral of 1 upon u, then times dx. So our dx is du divided by cos of x. And when you look at this, you realize now again this can be in form of du divided by u times cos of x. So you need cos of x. You will need to put this one in terms of again u. That is 1 minus sine squared, which is 1 minus u squared. So that is where you will land to. So clearly now we are at this given step. Now from this given step, another question would be, what are you going to do? Because you have 1 over u into the square root of 1 minus u squared. So here you cannot again use what we call partial fractions. So partial fractions cannot work. And again, if at all you are to let again u to be in terms of sign, you are coming back to the same question. So you realize actually you are hitting a dead end. So this is a dead end. So possibly it will be hard for you to integrate this kind of expression. So next, so this is for a person who solved of maybe letting u to be 1 plus sine of x. That is one person. Some of us have thought of that. But let us look at another person. So we are looking at the initial thoughts that majority would do just on seeing this given kind of integration. Two, another person would think about taking another pass where you will let t to be tan a half of x. Then you have your sine of x. You have your sine of x. You have your sine of x as 2t upon 1 plus t squared. So someone would also think about this. But another question rises, is this one the best method? So let us go on. If someone thinks of this, what do you think will happen? It means the person will have a dt as a half, a sec, a half sec squared, a half of x dx, which means dt will be same as a half into 1 plus t squared dx. And the person would go on and get dx as 2 dt upon 1 plus t squared. So the person would again substitute in this given expression. And this would mean the person would have 1 over integral of 1 over 1 plus this is 2t upon 1 plus t squared, then times 2 dt upon 1 plus t squared. So the person would think about this. So you need to get the LCM here before you cancel this. And the LCM, this would give us 1 upon, this is t squared plus 1 plus 2t. Then again times, this would be 1 over t squared, then times 1 plus t squared here. Here we have a 2, this is dt. So this and this would cancel. Still you would remain with the integral of t squared plus 2t plus 1. So someone would again think about such a method. But this method here is a bit wrong and it is error prone, especially if you mess up with something small. So these are the first assaults that the majority would think when they simply look at this question here. So now let us see what exactly would be the real solution, which would be easier for any of us. So the real solution, the one that the top students see, does not even start with the calculus technique. So it starts with just a clever move, just looking at what you are given. So basically the secret to this problem isn't the integration. It is how you rewrite the problem before you integrate. So the most powerful tool here you have is just the conjugate. So what we would exactly do here is you have the integral of 1 upon 1 plus sine of x dx. You have something like this. So what you would do is to simply look at this. Then you try to think about the conjugate of what you have in the denominator. So when you see 1 plus sine of x, then in the denominator, your mind should immediately jump to its algebraic pattern. And its algebraic pattern is 1 minus sine of x. So this is actually the moment that would create the best solution. So what would be the key here? The key is to multiply the conjugate both in the denominator and in the numerator. So we would have this as the integral of 1 upon 1 plus sine of x into 1 minus sine of x. Do multiply this one both in the numerator and the denominator. So 1 minus sine of x, then you multiply by your dx. So that is basically what we are having. So from here, you realize this would be the integral of 1 minus sine of x divided by, this is a difference of 2 squares, 1 minus sine squared of x dx. And this would be same as integrating 1 minus sine of x divided by 1 minus sine squared of x will give us cos squared of x, then dx. So clearly, we can see when we look at what we have so far, it looks much easier and much better now. So the denominator is now a single term, which means we can now split the fraction apart. So we can now split this apart. So from here, we can now have this as the integral of 1 over cos squared of x minus sine of x over cos squared of x, then dx. So if you have a single term in the denominator, it is always important that you split. So from here, it means we are having the integral of sec squared x minus, this is sine over cos, which will give us tan. So this will be tan of x, then sec of x, because we shall remain with, this is same as having sine of x over cos of x, then times 1 upon cos of x. So that is basically what we shall have. And this is into dx. So I hope now it is becoming more clear. So from here, after splitting, of course, we shall have sec squared. We can again now deal with integration. If you want, you can try to split this one to have this as the integral of sec squared x dx minus the integral of sec x, then tan of x dx. So that is what basically we shall have. And of course, we know how we can integrate this. So to integrate, when you are integrating sec squared of x, you get tan of x. And when you integrate sec x tan of x, you will get what we call sec of x. So that is what we shall get, then plus c. So from here, I hope now we are able to get the answer, and we have got the answer easily just by thinking about the conjugate of what we have in the denominator. So from here, it is clear that the integral of 1 upon 1 plus sine of x dx is same as tan of x minus sec of x. And because it is an indefinite integral, don't forget putting the constant of integration. So forgetting the c is one of the most common mistakes and is a point to lose in an exam. So whenever you integrate and you are having an indefinite integral, that is an integral that has no limits, please don't forget the constant of integration. So I hope you will take a second to appreciate how elegant that was. We started with a problem that felt actually like hitting a dead end, but a normal U substitution went nowhere. Even with the tan substitution, we were even increasing more of the problems. So it is clear that the move that we have taken of thinking about using what we call the conjugate is actually making life easier. So that is basically some of the few problems that usually come into the final examinations. So you need to be very careful, especially when you are to look at some given questions. So try to think hard, and try to think about how best you can easily solve the problem. So that is basically how we can easily solve that. And for those that were able to think about multiplying by the conjugate at the start, a massive congratulations to you all. That shows the kind of mathematical intuition that sets top performers apart. You didn't just see a rule to apply, you saw the structure of the problem and the key. So the real lesson here isn't just the answer to this one problem. It is just the mindset. So when you are up against a tough integral, especially in your final examinations, don't just charge ahead with the first technique you can think of. So just take a breath, ask yourself, can I simplify this first? Is there a trig identity I can use? Is there an algebraic trick like the conjugates? Can I split the fraction? Often the hardest calculus problems are really tests of your algebra and trigonometric skills. So whenever you meet such questions, the calculus part is just the final easy step. So mastering this problem solving approach is what will take you from a good student to a great one. So please, if this breakdown helped you to finally understand this infamous problem, do me a favor and hit the like button and subscribe to this channel. It really helps us to grow and reach more students who are trying to conquer these exams. Now for your bonus round, let's see if you truly mastered this concept using an exact same problem. Try to solve this integral. So this one is integrate 1 upon 1 minus cos of x dx. It is a different problem, but the core idea, the key insight is exactly the same. So go through the steps, multiply by the conjugate, use the Pythagorean identity, split the integral, and solve the two standard forms that may pop up. So once you have got your answer, post it in the comment section. I want to see how many of you can nail it. Thanks for watching, and I will see you in the next video.
Yeah.